Hi everyone, it's me again, Mrs. Bertrand. I come to you from my closet. Hopefully the sound is okay. I've heard this is the best place to record. So I'm sitting on my floor in my closet right now and bringing you this exciting activity. So we're going to be doing an introduction to equilibrium because right now we have no idea what equilibrium is, and this little activity is really helpful in terms of visualizing what is going on and getting some really good content afterwards, which we'll see for the rest of this unit. So here's what you are going to need for our activity: a piece of paper and a pencil, a calculator, 100 of the same item. I know this seems like a big ask, but find something small in your kitchen like rice, lentils, kernels of corn, beans, all kinds of stuff in there, and count out 100 of them. Don't touch them all. Use a spoon. You don't want to have to waste them, and don't put them back after you've handled them, please, for goodness sake. Don't worry, 100 is not as many as you think it is, actually. And if you can't get 100 items of the same thing, you can use pretend items and just go through the motions of this activity. All right, your next job on your piece of paper, you're going to set a table up that looks like this. So we have column 1, trial number. The second column is the reactant, and our rate for reactant exchange is 0.2, and then we have products with a rate of 0.4. So set this up, pause the video, and then go to the next slide. So the scenario that we're setting up is a reaction in a beaker. So your tabletop is essentially going to be your beaker, and right now your 100 items is representing the reactants in the beaker. As time goes on, reactants become products, and what we're going to see is what happens during equilibrium. So we're going to be exchanging the particles that you have. So let's say you've got 100 pieces of rice. Your left hand will be your rice pile and your left hand will be your reactants. Usually we do this with a partner, but because there's only one of you, your right hand will be your products, your partner hand. So basically we're going to exchange between the right hand and the left hand to represent what actually happens in a beaker. And what happens during an equilibrium reaction is there's actually a constant exchange of particles. So we're going to see what this looks like in practice and also numerically on paper. So we're going to set up that table once again. All right, time to get out our calculators. We're going to figure out how many items we need to exchange between reactants and products, and the rate of exchange, 0.2 and 0.4, is how we figure this out. So for the reactants, your pile of rice or whatever you've got, you're going to take your 100 and multiply it by 0.2. You're going to get the number 20. I'm just going to put it down here in brackets for us to keep track of it. Products, 0 times 0.4, your exchange rate is 0. So what you're going to do now is you're going to count out 20 of reactants, whatever your items are, and you're going to pass them to the product side. And products, your right hand, you're counting out 0 items. You've probably already counted that much out, and you would pass over to the reactant side. Now you're going to set up your next trial number. Now that we've actually done something, we're going to call this trial 1, and we're going to count how many each of the sides or parts of our reaction have particles. So reactants, you guys now have 80, and products, you guys have 20. So we should have 2 piles now. Left hand has 80, that's the reactant side. Right hand, 20, that's the product side. Now we're going to exchange again. We're going to keep doing this exchange until we reach equilibrium. Now, we don't really know what equilibrium looks like, but I bet we're going to know it when we see it actually. So again, we're going to take 80 times 0.2 for the reactants. That gives us 16. And products, you guys are 20 times 0.4. That gives us 8. So once again, the left hand, the reactants pile, you're going to count out 16 and give them to the products. And products, you're going to count out 8 and move them over to the reactants. So the piles are going to shift in both directions. Once you've done that, you're going to add your next trial and you're going to do it again. So at this point, we should have 72 reactants and 28 products. Same drill, count them again. So 72 times 0.2 is going to give us 14. 28 times 0.4 is going to give us 11. And once again, we're going to count out these number of particles from the left and pass them to the right. This number from the right, pass them to the left. You're going to continue this down until you think you have reached equilibrium for me. So keep going until you think you've reached equilibrium, and then we will chat. All right, you should have reached equilibrium at trial number 4. At trial number 4, we had 67 reactants, and our exchange rate was 13, and we had 33 products, and our exchange rate was 13, which means when we move them to opposite sides, we end up getting the exact same number. 67 and 13, 33 and 13. Just for visual sake, what I want you to do now is to add a few more trials of the same type. All right, so let's take it up to trial number 7, and we have some repeated data here. That's going to help us later on to see something visually. So for now, don't worry about that. Now what we're going to do is we're going to disturb the equilibrium. So here's what you're going to do. You're going to take away 20 items from the reactant side, and you're going to put them off to the side so they are no longer in play. You can pause the video at this point to count them out and push them off to the side. Now we're going to reset, and what we're going to do here is we're actually going to take out the 20. We're going to call this trial 7 again because we haven't actually moved any particles, but we're going to show what our starting values are from this point forward. And what we're going to do is we're going to now exchange particles again, excluding the 20 that we pushed off to the side, and we're going to see what happens to equilibrium when we've disturbed it. This kind of disturbance is a concentration disturbance. I've taken some out in terms of that. So we're going to try to do the exchange again, and we're going to keep going until we think we reached equilibrium. So let's get our game on. So 47 times 0.2 gives us 9. 33 times 0.4 is 13. Again, I didn't mention this earlier, but you will always round to a whole number since you can't break up your little pieces of beans or rice or whatever you've got. So again, we're going to push 9 this direction, 13 are coming over here. And so for trial 8, we've got 51 and 29. I want you to keep going with this. Now that you know what you're doing, you're going to keep going until you think you've reached equilibrium here. And then just like we did before up here, I want you to add a few more trials, like 3 extra ones, just to have that data repeating itself, because that's going to become important to us. So pause the video, keep going with it, and see what happens. All right, this is all of the data that you should have collected right from trial 0. And what I want you to do down here is I want you to add trial 11 and 12 for me. Again, just repeating that same data because again, once again, we've reached equilibrium at this stage. Now what I want you to do is I want you to plot the data. So here's what the lines look like. So on the left-hand side, you're going to have your number of items, and you have A and B. So we're going to go from 0 at the bottom to 100 at the top. It's not a really formal graph. We just want to have a look at the shape that occurs. And then down here we have our trial number, so we're going to go all the way up to trial 12 here. You're going to sketch both of the items. So for instance, you might want to color code them and do all the dots for A first and then do all the dots for B second and just color code them after that. And again, this is where you're going to pause the video to do that part. Here, A is going to be referring to the reactants and B will be referring to products. So this is roughly what your graphs should look like at this point. And I do mean roughly. And a couple of really key things here is what does equilibrium look like on a graph? We're going to see this in further units into this particular section of the course. And so we want to know how to identify that. So the equilibrium sections are actually these ones that are horizontal. So when things are horizontal, that means we've reached equilibrium. So again, that will be helpful later on. So now that you've got this information, Hopefully you have a better understanding of what equilibrium is, and if you consider passing particles back and forth from left hand to right hand forever, that's essentially what happens in a beaker if you have an equilibrium reaction going on. Not all reactions are equilibrium reactions. Lots of them are one-way arrows and they only go reactants to products and not in the reverse. But there are this special set of reactions that go in both directions. Reactants become products, products become reactants. And that's what we're going to be dealing with in this particular section of the course.